Okay, so the answer to number 23 is how is the maximum value of this function shown on the graph of the function? So how do they show it? There's lots of different ways. How would a minimum value be shown? You could say it's the highest point, the maximum value is the highest point. And if it was a minimum value, is the lowest point. That would be the easiest way I can think of to do it. Okay. So now let's take a look at this problem as it shows you right here. We are looking on page 110 and 110, number 16. Let's see if we can move it up a little bit. A customer fenced me in, wants to increase both the length and the width of the rectangular fenced area in her backyard by X feet. Okay, let me make sure you see what's happening. What's the situation here? We have the backyard. It says it's a rectangular backyard. Boy, my rectangles are lacking. And they want to make this distance longer by X. Both the length and the width be increased by X. So this number right here needs to be brought down, and then this same measurement right here. So my new fence is going to be the size of the, good grief, the size of the red thing. So the length right here is the old length plus X. And the width right here is the old width plus X. Okay, so it says right here that if we multiply this thing right here times this thing right here, we get this. So that means for part A, you do exactly what it says. You factor this. Okay, and you should recognize that this is an easy table. And why is it an easy table? Because this number right here is 1. I'm not going to do this for you, but you know that the 200 has to go right here, and that you need to think of numbers that multiply together to give you 200. I don't know, 100 times 2. Let's see, 25 times 8. What about 10 times 20? And of course, you're trying to see that which ones combine together to give you 30. And then whatever you find, whichever number you pick over here, one's going to go here and one's going to go here. So once you get it factored, part B wants to know what are the original length and width of the fence. So remember, the new length is going to be X plus whatever the old length was. And this one right here is going to be X plus whatever the old width was. So these two numbers right here, okay, whatever you put right here, that's going to be the original length is, and the original width is. So you'll want to put these two numbers as the answers right there. Okay. Let's move this over here. I'm now on page 115. Let's see, the manager fits me in. This function right here models the yearly profit. So I'm sure P stands for profit. And as long as we sell the gate latch for S dollars, okay? Remember, I can't write the letter S without it looking like a 5. So I'm going to do the cursive letter S. And someone thought today that that was a triangle, but that's not. It's my cursive letter S. So anyway, it says write a quadratic equation that can be used to determine the selling price that results in a yearly profit. So they're telling me right here, this is my profit. This is my P of S. So my answer to part A is to simply write the equation negative 4s squared plus 400s minus 8,400 and set it equal to 1,600. So I did that. I did what they said. I took this problem right here and I set it equal to, of course, I just rearranged this one. I put this first and I put this last. And I substituted in this 1,600 in for the profit because that's what it is. Now, part B says, let's write this quadratic equation so that it's in standard form and it has a leading coefficient of 1. That means they don't want the 4 there. Well, if we don't want the 4 there, how can we make it go away? Well, first of all, it's not in standard form unless it's set equal to 0. So I'm going to start by setting it equal to 0 and subtracting that from both sides. So I'm going to do negative 4s squared plus 400s. Combine those like terms, and I think that's going to be a negative 10,000. And that's equal to 0. It still does not have a leading coefficient of 1. So I need to see, are all of these things divisible by negative 4? They are divisible by negative 4. So let's factor out that negative 4. S squared, 400 divided by 4, that's 100. Undistribute the 4. See, that's what I'm doing. So if I undistribute the 4, then 10,000 undistribute the 4 will leave me 2,500. Now, I also am pulling out a negative 4, so I messed up on my sign right there. Because if I divide 400, oh, of course, it messed up. So let me go back and rewrite. It's s squared. It'll be minus 100s because a positive divided by a negative. If I distribute that in, I need a negative right there for that negative and that negative to multiply together to give me a positive. And this will be 2,500, and that's equal to 0. So I now have a leading coefficient of 1. You can go ahead and solve it. I mean, since it's set equal to 0, you can divide both sides by negative 4, but leaving it like that is fine. But you can go ahead and divide both sides by 4, negative 4, because you know that 0 divided by 4 is going to be 0. And then part C, solve the quadratic equation by factoring. Okay, again, now that we've got it like this should be an easy table. This is an easy table. I'm not going to do it for you, but you can set the table up. It's 2,500, and you're going to need 2 negative numbers. You could do 25 times negative 100. Okay, but they also have to combine together to give you a negative 100, so that won't work. Negative, I think 50 times negative 50. I don't know, there should be some more, but I think that should work. And what are you doing? You're looking for what 2 numbers go here and here. So fill those blanks in with the right numbers. And then, of course, set those 2 things equal to 0 and solve, because they ask you to solve it, not just factor. It says solve by factoring. And be sure you interpret the solution. Remember, if it says S equals something, that tells you that that's what the selling price should be, the selling price. So you're going to interpret the solution. You're going to say